Algebra 2, Concept 47, the normal distribution. Earlier you learned about looking at a sample of a population to gather data. Descriptive and inferential statistics are used to make statements and predictions about populations of items or individuals. Often it's helpful to see the data collected in a graphical representation. These graphical representations are data displays, and that's what we'll be learning about in this concept. One type of data display is a curved graph comparing data values with the frequency that the values occur. If you look at the three graphs below, these are three examples of curved data distributions. So notice on each of these three graphs along the x-axis we would have data values. We haven't named what they are, but just in general they would be some sort of data set, like test scores or heights of people. And then along the y-axis we have the frequency that values would occur. Now in the middle, this is a type of curve called a normal distribution. And so if you look at it here, marking the origin for the x and y axis, it's the data values compared to how many times those values occur, frequency. So right in the middle, and on the data values, it goes just like normal, so low numbers up to high numbers. So if you look at, most of the values fall right in the middle of the data set, and you'll see three terms that you should be familiar with: mean, median, and mode. In a normal distribution of data values, the mean, median, and mode all will be virtually the same number and occur in the middle of the data set. We also have examples of curves on the left and the right side of the normal curve. So on the left you will see a left skewed data curve, and that's where the majority of the values pile up at the upper end of the data values. And then we have a right skewed data distribution, and that's where most of the values pile up in the lower end, or the left side. But we name those skewed distributions by where what we call the tail of the curve is. So if they pile up on the right, the curve is on the left, and we call that a left skewed. And if they pile up in the lower end to the left, we call that a right skewed. So that's in general a curved data display with a normal distribution, a left or a right skewed distribution. Let's get some specific information down about these data displays. So a normal distribution is a data set where most of the values cluster in the middle of the range with the mean. And then the rest taper off to the right and to the left, so with increasing and decreasing values symmetrically or evenly. The curve is described as bell-shaped. So it rises just in the middle and then it tapers off evenly to the right and to the left, or as the data values increase and decrease. A left skewed distribution data set is where most of the values cluster at the upper end of the data set. So that would be data like you're in a class and you take a test and you all do well. And so your scores would pile up at the upper end, and that would be a left skewed distribution. A right skewed distribution is a data set where most values cluster at the lower end, and we call that a right skewed because we look to where the tail of the curve is. So that would be if you were in a class and overall the class did not do so well. So your test scores would most likely fall on the lower end. There's another type of data display that I'm going to show you on our next screen, which is called a histogram. You've probably seen these before. It's a display of statistical information that uses rectangles to show the frequency of data items or values in a successive number of intervals. So look at the lower kind of leftish side of the screen at that histogram. It's kind of hard to read, but this is an example of one showing the frequency of days and number of page views of a Japanese Wikipedia site. So we have page views along the x-axis and then frequency of days along the right. So we can see page here page views, and then so this was after day 1 and then day 2. So we're going to draw a curve across the top of these rectangles so we can turn this into one of the type of data displays we've just been talking about. So I'm going to follow the shape of this, and then it falls off. So where do most of the data points occur? Well, most of them occur in the upper end of our data display. And so that is a left skewed distribution. So let's just get down. Where do most of the data points occur, at the right or the upper end? So we can look at this as a histogram, but we can also see that curve across the top, showing just what that would look like, and then that would be a left skewed distribution. We're going to continue to talk about data curves, and we're going to focus now on the normal curve. So the value in the middle of the curve is the mean, and we use the Greek letter mu. It looks like a stylized M. And so look down at the data displays. You can see that mean shows up right in the middle. You also see it repeated to the left and to the right, but I'll explain what that means in a moment. So that's the value, that's the average, and occurs the most frequently. The distribution of the curve is predictable in that 50% of the data values are above that mean, that middle or average, and then 50% are below. The average distance from the mean is another statistical measure that we talk about, and so that is called standard deviation, and we use the Greek letter sigma. So this would be mu, and this is a sigma. So each upper and lower 50% is divided into 3 areas. So 1, 2, and 3 standard deviations from the mean. A standard deviation is just the average distance from the mean, or it's like a step away from the mean. So look down at the data display again, and we can now see that we have right in the middle that mean score, that mu, and then the next mark would indicate 1 step away, or 1 standard deviation. So that's why it says mu, or mean, plus sigma, and then mean plus 2 standard deviations, and mean plus 3. And then we can go 1 step in the negative direction, 1 away, 2 away, and 3 away. A predictable percent of the data in a normal curve will fall within 1, 2, or 3 steps or standard deviations away from that middle or mean number. So they can be interpreted as follows. So in a normal distribution, about 68% of the data values will be just 1 standard deviation from the mean. About 95 will be 2 standard deviations, and about 97.7 will be within 3 steps or 3 standard deviations. Now, if you look at the curve on the right, I want to show you the specific breakdown of how the distributions fall between each standard deviation. So from the mean to 1 standard deviation above, about 34% of the data values will be there. And if we go down in the negative direction, about 34 will be between the mean and 1 below. And then if we keep stepping down, about 13.5% of the data values, 13.5% of the data values will be from 1 standard deviation below to 2 below. So from 1 below to 2 below. And then on the corresponding, on the right side, when we increase, it's the same. So from 1 above to 2 above, 13.5%. So you will use both configuration of how the data values distribute or fall in a data set later on in the concept when you answer questions. If you look at the bottom of your screen, I have an actual normal curve that was taken from data given from an actual survey to Liberty Public Schools. It's the Panorama Survey. You may have taken this before if you're a Liberty student. So this one in particular shows results of the question, how well students consider the perspective of others and empathize with them. if you're interested in that. Now, the curve shows all of the respondents nationally, and then it gives a little label where we fall as Liberty Public Schools. So this is where these data distributions can come in handy, because once school administrators get these back, they can look and kind of judge, okay, how are our students doing or feeling or perceiving things compared to other students in the nation. Now let's look at the bulleted points, and let's look at the first bullet. So this normal distribution shows that the mean or average percent responding favorably to how well students consider the perspectives of others and empathize with them is 58%. And so that is right down. I'm going to go ahead and mark it here, 58. 65%, so here's the second bullet point, of Liberty's secondary grade respondents, they responded favorably. So right away, if I'm a Liberty administrator, I'm saying, oh good, our students are responding higher than the average. And data distributions can show us like a range of, how people responded. So the third bullet point says, notice the curve of the values tapers off in a fairly equal manner to the right and to the left of the highest point of that 58%, creating a range of approximately 30% to 75%. So if, again, you're an administrator, you're just looking at this data, you can know that the school district's students responding the lowest would be about 30% and up to 75%. So at a glance, these data displays, these curves, can help us interpret and understand data, especially when it has comparisons for our data compared to others. Here's another actual normal curve that I would like for you to look at. It's not made up, okay? It is based on some survey data from that panorama survey, and it is showing the results of 5,355 responders responding to a question about grit and questions about grit. And grit is defined as how well students persevere through setbacks. So at a glance, and we can say, well, how are they responding? Along the x-axis, this is showing the percent that are responding favorably, meaning that students can persevere through setbacks, that they do have grit rather than responding unfavorably. So right away, that middle mark, it's kind of hard to read down below, but it shows that the most of the respondents, meaning about 60%, respond favorably. And then you can see our 3 standard deviation steps in the positive and in the negative direction. So let's look a little further at this graph, and then we're going to answer some questions about it. So what is the mean percent of this data set? It is 60%. And I'm telling you that the standard deviation, sigma, so that's the average distance from the mean or the average, is 9. So to explain this, we would say that the average distance from the mean of responses 60 is 9 percentage points. Now let's label those standard deviation lines. So I've got them nicely labeled, but I'm just going to start over for you. So we know that the mean is 60. And then our standard deviation is 9. So I'm going to add 9, and then that will give me, my next mark is 69. And then 9 more would be 78. And then 87%. And then one standard deviation below would be 51 and 42 and 33. The percents labeled inside the area between standard deviation values are the percents of the data values that will fall within that interval. So they are 34 and 34. And then from 1 to 2, 13 and a half and 13 and a half. And then from 2 to 3, 2 and 35 hundredths. And then from 3 and above, 15 hundredths. We're going to label the intervals of 68, 95, and 99.7. So 68% of the data values will fall right here. One standard deviation above or below, one step above or below the mean. All right, and then 95 will fall within 2 standard deviations. And then with my green, so all the way from here to here, 99.7 of values in the data set will fall. In the second video of part 2 of concept 4D7, we're going to continue. We're going to look at some more examples and problems with the normal curve.